Fiction and reality. New stories, new ideas. Little Beth Entertainment.
Hey, welcome to the Model Rocket Show at TheRocketryShow.com. I am your host, The Rocket Noob, and welcome back to the podcast. Elephant in the room. Yes, we have been gone for a while, several months, and so I've had a few questions about it. What's going on? Are you on hiatus? Is the show still happening? And so let me just talk to you about it a little bit. So you may have noticed the last couple of years have been a little stressful for people due to things like pandemics going around and just general world events happening. And it's gotten to a lot of us, and it's gotten to me as well. I've had a lot of stress, and I've had a lot of distractions, and some of them have been, the same distractions as everybody. And a lot of it actually for me in particular has been things like job stress and other things like that. So I've just had a lot on my mind and a lot on my plate. And I've found it very hard to stay motivated to work on a project that I do just for fun. And frankly, I've been a little, should I say this? Yes, I've been a little depressed over the last year and a half, 2 years. It's been hard. And so, I've found it very hard to focus on rocketry, which is something I'm passionate about. If I weren't, I wouldn't be doing this podcast. But I went through a period where I even sort of started to question, do I really still like this hobby? And a few months ago at a launch, I was talking to a friend. I said, it's been a year since I've built anything. And I used to build all the time. And he said, me too. And we both agreed that that's kind of a barometer for how we are doing. I don't want to over-dramatize this. There have been a lot of really good things that have been going on. My family's doing very well in a lot of ways. I've gotten into much better shape this year than they were in years past. And so, not everything is grim. It's just been a little hard for me to focus. And the last couple of months, I've started building again. If you read my blog, rocketnoob.blogspot.com, you'll see I started building some rockets. I decided it was time to get back into this hobby, which frankly for me is a stress reliever, and actually enjoy it and start posting things. So I've been posting things on the blog and on Instagram and Twitter. And I am going to be doing the show, but things are going to be a little different, at least going forward for at least a time being, until I can get some things sort of sorted out and have more energy and time. Really, it's time to focus on this podcast and make it what it should be. I mean, I even talked to CG of The Rocketry Show, the producer of the show, the creator of this show, and I said, I don't know if I should be doing this anymore. I almost feel like I'm getting in the way of the show. So what we're doing temporarily is I'll be here to introduce the show and pop in every now and then and do an occasional episode. But starting with this episode, at least for the time being, Gheem and Jesse, model rocket guy Jesse, are going to be sort of sharing hosting duties with me. So this episode is going to be a deep dive into a subject that when we first conceived this show, we sort of talked about, and then we ended up surging forward with some more advanced stuff and some interviews with some great people. But it is a deep dive into the model rocket safety code. Very important, basic thing, especially if you're new to the hobby. And maybe you don't know the names of some of these people we've been talking to or what have you. It is a deep look at the model rocket safety code. I haven't heard it yet, so I am looking forward to listening to it with you when it comes out. But let's talk about a sponsor of the show, RocketryForum.com. The Model Rocket Show thanks the Rocketry Forum for their support. This is El Corinth. When I joined, I didn't think about branding myself as Rocket Noob. So I've been El Corinth. I've been a member since 2014 when I first got started in this hobby. The Rocketry Forum is a global community of Rocketeers who openly discuss all aspects of hobby rocketry. So if you have a question, hop on and ask. There are hundreds of experts who can answer just about any rocketry question you have. So check them out today at RocketryForum.com. All right, let's listen to what Gheem and Jesse have to say about the model rocket safety code. The show starts in 5, 4, 3, 2, 1.
Welcome to the Model Rocket Show, a podcast that is all about low and mid-power model rockets, like the ones you buy at hobby stores and fly in a park. And now, here is your host, Daniel the Rocket Noob.
Hey, welcome to another edition of the Model Rocketry Show. I'm Gheem.
And I'm Jesse, you model rocket guy.
And we're here today helping out the noob. He's got some things going on, but it's always good to help out in the rocketry world, which we all like to do. So our topic today is going to be a good one. It's basically for people that are not real familiar with about rocketry, because there's been a big surge. I don't know if you've seen this, Jesse, or not, but I know all over Twitter with hot nozzle summer and everything going on, there's a lot of people that are beginning to get interested in rocketry that don't know anything about it. So
it's very true.
Absolutely. And we were kind of putting our heads together a little bit, and we thought, well, we're for somebody that really wants to get into rocketry but doesn't know anything about it, what's a good place to start? And we came up with, let's go over the National Association of Rocketry Safety Code. And that essentially is the guidelines for how to actually fly model rockets safely and not get into any trouble. And if you follow the little steps on this code, you will have nothing but good. I can't say you're going to have good flights. That depends on your rocket and the motors and all that stuff. But you'll certainly be safe. So we figured we'd jump right into it. And little history about the Model Rocketry Safety Code is that it has been evolving since the 1960s. When the National Association of Rocketry started, it was started as an organization because people were doing things that were not necessarily safe. They were using fuses, making propellants, doing all kinds of things that they shouldn't. And the National Association of Rocketry got together and realized that in order for this hobby to grow and continue on and doing all the good things that they do, there needs to be a safety code. So it's real simple and basic, and we're just going to go over the points to kind of talk about it a little bit, just to kind of dip our toes into what's the best way to do something. So with that in mind, there's about 11 points, and we're going to go back and forth on it, and we'll just kind of talk about it. So I'll start out with the first one. This is the National Association of Rocketry Safety Code. The first point is, doesn't it though? I hope so, is materials. What do you make your rocket out of? And I will use only lightweight, non-metal parts for the nose cone, body, and fins of my rocket. It sounds pretty basic, right, Jess?
It does. And, everybody that, you touched on a point just a second ago, with hot nozzle summer, all the people doing L1 certifications for high power rocketry, remember our focus is model rocket. So this is the Model Rocket Show, and we want to go over the Model Rocket Safety Code. So obviously, we know you have metal tips and cool fiberglass nose cones for high power rocketry, but for everybody, keep in mind, this is Model Rocket Safety Code. And yes, I agree with this wholeheartedly. I mean, you don't want metal on some of the small cardboard rockets, man, because it'll probably never lift off. But that's another thing we can talk about.
And even if it does, if it comes down and it doesn't, and it'll get into some other points of the code. But if it comes down without any kind of good recovery, that could be dangerous. And you could not only do property damage, but you could also hurt your head too. So you don't really want to do that. So basically, what kind of materials are we talking about? What do you think? Cardboard.
So yeah, cardboard for the tubes, something lightweight. And if you really pick up just like a BT50 tube, it weighs nothing. I mean, they are so tiny. And then
that's true.
I was looking at some of the Estus kits I have here, and the fins, balsa fins, and I love touching those sheets when they're either die cut or laser cut. And that sheet itself is so lightweight. So that's the key, guys, is lightweight parts. And then most of the nose cones that we have now for our kits are made of plastic. And even from, when the rocketry first started, a lot of that was done with balsa wood. And at the same time, when you pick up a balsa wood nose cone or like a balsa transition, it's also very, very light. So, with the key of that for the materials, all of your, Estus beginner kits are going to have that. Now, some of the ready-to-fly rockets and almost ready-to-fly rockets will have more plastic parts, especially for the fins and the booster. And that's cool. But if you notice, the body's still lightweight tube, and, you got the smaller parts that make up the recovery and everything, and it's all very lightweight. That's why your model rockets can stay under a pound and fly on Ds all the way down to half As, or quarter As.
Yeah, quarter A's. The lighter the better with this, guys, because if you're flying a rocket, I mean, we all want to see it go high, right? I mean, there are certain circumstances where we don't want it to go too high, but keeping light is the key. Jesse's absolutely right about that. So, there are also some Estus kits that have cardstock fins too that are even lighter than balsa wood, which are kind of fun. They're small, they go together very easily. And if you take your time and just make sure you build properly, like use the right glue and just, and that's all in the instructions that you get usually. It might be wood glue, it might be super glue, or it might be whatever the instructions call for. Just use that glue for now. It's a good way to get started with it. And then you can get into other projects as you go on the line and in your transitions and go for it. So, but keep it light and fly high.
Building all the way up, as you go. So the second rule to the Model Rocket Safety Code is the motors. So as it states, I will use only certified, commercially made Model Rocket motors. That's key. I will not tamper with these motors or use them for any purposes except those recommended by the manufacturer. So a lot of you guys are on groups. And what kind of advice are people getting on the groups, And it's absolutely it's the most basic thing to think about, but you don't want to we've all seen some of the YouTube videos out there where people are making motors out of sugar and other things like that. Don't. Just flat out don't. It's dangerous. It's not going to enhance your experience. The thrust on sugar motors is not that great anyway. You're probably going to get better performance out of using a commercial Estes or Aerotech or Cesaroni motor anyway. So, and then, I have a lot of people that ask if they remove this or if they do that or if they take a drill and do this, don't modify. One of the reasons that the Model Rocket motors are the way they are is because they're supposed to be simple, quick, and that brings us into our next, how we actually light those motors.
So absolutely. That brings, thank you for that transition. Going right into the ignition systems is what they call it. It's basically what you do to get the thing off the pad. I will launch my rockets with an electrical launch system and electrical motor igniters. My launch system will have a safety interlock in series with the launch switch, and we'll use a launch switch that returns to the off position when released. Now, that sounds a little peculiar, but if you think about it, it actually makes a lot of sense because when you're not hitting that button to launch that rocket, you do not want that system engaged. You don't want any kind of a signal because they're more than likely when you go to fly rockets, if you go to a club launch, they have multiple pads and they have a bunch of rockets on the pad ready to go. And you don't want to get near a rocket when it's launching, even if it's a small one, even if it's a half A, you don't want to light it with a match because that could be really dangerous. There's stories of guys getting burned back in the old days and having, rockets motors that kind of blew up on them because they modified them like we talked about. So the safety system, also, using an electrical system gives you the ability to keep a safe distance. So it's, think of it like fireworks in some ways. You have to, you don't want to light the fuse and get away because this isn't a firework. But, and as long as you are just kind of following that, using that electrical system, a safety interlock is kind of like a little launch key that you put in to complete the circuit. And then you have another button to press when it's time to launch. So it's kind of just a little built-in safety stuff to make sure that that you're going to be at a safe distance when you launch it. And using electrical, it's a lot more precise than a match, I guess. So what else do you want to add to that, Jesse? Do you got anything else on that?
Yeah, actually, a couple of things. So, we're recording this and going over the safety code, and a lot of the folks that listen to our podcast and listen to the Rocket Noob Talk on the Model Rocket Show that we're helping out with here, they're already experienced Rocketeers. So we're speaking to you, the new person who went out to Hobby Lobby or Hobby Town or any hobby store and bought yourself a launch pad, a rocket with a few motors and a launch pad. We'll talk more about the launch pads in number 6, but for right now, just focusing on the ignition system. In most cases, just like Gheem was talking about, you're going to have a handheld controller, and it's going to have that pin that completes the circuit, and as soon as you take that pin out, that basically stops the circuit. And just like it says here at the end of number 3, it returns it to the off position. So one of the mistakes that I made in those Estus controllers, for example, is when I got back into rocketry, I was like, how come this isn't working? How come this isn't working? Well, when you put your pin in, hold down on the button. And then when you release it, it goes back to the off position. So I was pushing the button, and if my AA's were strong enough and it put out that current, which is going from the controller to the actual rocket itself, that might be a tip
Yep.
for everybody, is just hold down on your button for a minute. And then when you release it, pull your pin after the thing takes off. You can still keep your eyes on your rocket. Just, try to remember while you're looking up, pull your pin, and then your stuff is good. So that's just a tip for all you new persons.
And that's a simple launch system. And every launch system, even if you go to the big club launches, it's essentially the same exact type of situation where you've got this interlock that goes on or off. And then there's there might be another switch to select the pad because it's multiple pads. And then finally is the launch button after the launch person looks over things. At a club launch, you're going to have what's called a launch control officer. That's the person there that does the launching for you. If you're just on yourself going to a park to fly an Estus rocket on an A motor, obviously that's going to be a little different. But the system's still the same. It's just a little bit bigger. Now, there are some times where if you do everything and you do it right, the rocket still does not launch, and that's called a misfire. So why don't you hit number 4, Jesse, on that and see where we go from there.
And they do talk about this in the safety code, just like Jim said. Number 4 is misfires. So as it reads, if my rocket does not launch when I press the button of my electrical launch system, I will remove the launcher's safety interlock or disconnect its battery, wait 60 seconds after the last launch attempt before allowing anyone to approach the rocket. So, we get back to fireworks because it's not because they're the same. That's not why. But we go back to fireworks because, if you light a dud and everybody's lit a dud, you don't go to it right away because all of a sudden that little spinner that you lit, it's going to take off again. The same kind of thing happens with misfires. I mean, we have seen situations, and it's few and far between, but we have seen situations where even that small little rocket motor could possibly light at the last minute and take off. So wait literally 1 minute before you walk over to it and just give it a chance to die down, because the ember at the end of that little starter that you're going to have to light that motor could still be red, and that might have enough juice to potentially cause the motor to take off. So just give it a minute and you should be good. What else you got on that one, Gene?
Yes, I do have a couple things to add because I have a personal experience when I was getting back into rocketry as a born-again rocketeer about 6 or 7 years ago. I was using a composite motor, which is a little bit more energetic than the Estus black powder motors. And they also take a little bit longer to light. They have a different kind of igniter or a different starter on them. And they sometimes take a little bit more time to get going. And I had a misfire. And it didn't look like it was doing anything. I saw no smoke. I heard no sound. It was just kind of sitting on the pad. So I waited probably about 30 or 45 seconds, actually, because I did count it out. I was like, I better not approach it. And I got to the point where I was walking toward it, and I was probably about maybe 15 feet away, 10 feet away, and it went off after that. So it must have been there on the pad, and it was just before a minute, that thing took off. Now, it was an F motor, which is a pretty beefy model rocket motor, and it scared the living daylights out of me, but I also learned, and nothing happened. It's nothing. I didn't get injured or anything, but it did remind me to follow that 60 seconds. So every time that happens now, I set a timer on my phone, and and for my team, my TARC team that I work with, I make sure that that if they do have a misfire, that they wait that 60 seconds. It's critically important. And, I just remember that one little experience, and I've never let that happen again.
And your launch control officer at a club will do the same thing. They will. Okay, if you're the last rocket, they'll tell you to wait before you go out there. In most cases, if you have a misfire, they'll go on to the next rocket. But like if you're on number 5 and number 5 was your last setup that you had, then they'll have you wait a minute before they open the field. And at that point, they'll scream out, range is open or something similar. So just
range clear.
Yeah, there you go. So just so everybody has an idea on that one.
And that's part of the safety, which leads directly into number 5, Jesse.
All right. So number 5, launch safety. I will use a countdown before launch and ensure that everyone is paying attention and is a safe distance of at least 15 feet away when I launch rockets with D motors or smaller, and up to 30 feet away when I launch larger rockets. Now we'll touch base on that in a second. The continuation. If I am uncertain about the safety or stability of an untested rocket, I will check the stability before flight and I will fly it only after warning spectators and clearing them away to a safe distance. When conducting a simultaneous launch of more than 10 rockets, I will observe a safety distance of 1.5 times the maximum expected altitude of any launched rocket. So that the launch safety for number 5.
Race.
Yeah, it's got 3 big topics there. So I'll reiterate on the first one here. I will use a countdown before launch and ensure that everyone is paying attention and a safe distance of at least 15 feet away when I launch rockets with D motors or smaller. Okay, so just to iterate on that, a D motor is a pretty big motor. And I remember CG talking about this on an episode of The Rocketry Show. He was saying, my dad and I, we thought, we'd have to graduate up to the D motors. You know what? I was kind of the same way. My first D motor was probably a couple years after I was launching A, Bs, and Cs. So, 15 feet is still kind of close if you really think about it. But that's what most of your controllers for your ignition system are going to have. They're going to have a 15-foot wire. And then you'll see that some of the larger Estus controllers in that have 30 feet wires. So yes, you can launch a rocket with an A through D motor on a 30-foot ignition system. That's fine. It'll put you a little bit back farther, and you might have to walk a little bit more. Not that big of a deal, because you're going to have fun either way. But 15 feet away for a D and smaller, that is definitely a big deal. I mean, Gene, when you were walking to that motor and it took off on that F, you were still within a fairly safe distance. But if it allows you the time to stand back. So it is definitely for safety. And I touched based on the 30-foot, controllers. Now, that usually goes up to potentially like a E or an F motor. And Gene, can you talk about that? What is the cutoff for Gs? I don't remember.
The cutoff for Gs is, I've looked this up. It's actually 30 feet, but you don't want to go any closer than that on a G. So it's the same. It's part of that. G is a little bit of a gray area because it's almost high power. Some of them actually are high power. Right. They're considered high power. So be careful with the Gs. I would say, when I work with my kids, I like to keep at least 35 to 40 feet away when we do Gs. But most of the time we're shooting Fs for TARC and doing so we're in the F range, which is that 30 feet. And I make sure that, my launch controller has 100-foot RJ cable, internet cable that I use in my system. So I've got 100 feet to play with, and I roll out at least, somewhere around half of it. So we're more like 50 feet.
Okay, perfect. So when you have an Estus controller and you have the Estus, for example, the Pro Series 2 controller, that does have a 30-foot cable. And that is capable of launching up to G motors fairly efficiently and fairly decently. Use your best caution on that. For example, guys, if you're building a rocket that takes up to a minimum of a G motor, like I believe the 4-inch Estus, what is it? The Megadur Red Max, right?
On the Megadur Red Max.
So that actually used a fairly high G motor to get it off the pad. Now, unfortunately, Estus doesn't sell that rocket or the motor for it anymore. So some of the motors that they do carry can sit within that 30-foot range. So I would recommend, if you're trying to do something over 30 feet or, anywhere between that gray area that James talking about with the G, I recommend going to, for example, the Apogee Rocketry website and look at some of Tim Van Milligan's videos, because he does explain the differences and, what you want to do when you start messing with the Gs and getting into potentially higher power rockets. At that point, it sounds like you might be ready to graduate into that. And then you will require a different type of launch pad, which might include a rail and not just a rod. And we'll talk more about that here in the next one for number 6. Right. And, we can keep going up the ladder as it goes there. But, just to pay some attention to the Gs, use some, I don't know, just use your best interest and, make sure that you're just doing that.
Common sense.
Exactly. Thank you, Jim. Just doing common sense. The second thing for number 5, technically, is talking about the stability of the rocket. So, Jim, you and I have talked about that before. Could you touch on that for a sec?
Absolutely. Stability of the rocket. There's 2 things that you need to keep in mind for a basic stability check. What is your center of gravity on the rocket? That's where, when a motor's loaded into it, where is the balance point for that rocket? And that is tied directly into the center of pressure, which is basically where the point of what happens when the fins start moving, or when the air starts moving over the fins, with the direction the rocket's going to take. And that balance point is going to be a little different than your basic balance point. The center of pressure is where the pressure is equalized for all air streaming through the rocket as it's going into the air. Now, those two things, your CG is your center of gravity and your CP, center of pressure,
Right.
are the two basic things that you need to know about whether a rocket's going to be stable. The biggest rule of thumb for that is the center of pressure needs to be at least one body caliper or one body diameter behind, or aft of the center of gravity. So a perfect stability factor would be one body diameter between those 2 points. Now, how do you figure those numbers? And you can go higher than that if a rocket's overstable. That's okay. But keep in mind, though, that the more overstable you get with a rocket, the more it's going to want to fly into the wind. It's called weathercocking, and that's a lot of people that just get started into rocketry. Like, they see the rockets go up, and all of a sudden they take a turn into the wind, and they're like, "Why did it do that?" Well, that's probably because it wasn't balanced properly, or the center of gravity was off,
Right.
or just your basic stability. Now, the big question is, how do you calculate all this? There's an old school method and a new school method. I'll talk about the new school method, and then Jesse, do you know how to do stability spin tests?
So,
do you remember that?
yeah, we can touch on that for a quick second if you want. So,
For a quick second,
yeah.
but
So when you're testing the stability of a rocket, what I was taught to do was kind of balance it on your finger and take a string, tie the string in a loophole just around the rocket where that balance point would be. You would take the rocket and just basically move it around your body and just make sure that it doesn't, look like the nose cone and the fins is like traveling sideways. If you see that happening,
Yes.
you're unstable. At which point you want to try to talk about
Absolutely.
nose weight. And nose weight in traditional model rockets is usually clay. There's other ways that you can add nose weight, but for most intents and purposes, if you have a plastic nose cone, you can just take a small dowel rod, take some clay, and shove in there. Now, how much clay do you use? Well, you can take your motor, and you can kind of measure it on a scale if you have one, or you can just take a tad bit of clay and then just keep doing your spin test until you have enough clay that it actually goes horizontal instead of sideways. And what I mean by sideways is it's literally like floating diagonally on your string. If you see that, that's not good.
Yeah.
So add a little bit of weight and then, try to figure it out. Now, in most of your kits that you buy, they will actually include a small, I can't remember how many grams it is, but they do actually include some nose weight if they suspect that maybe the fins might be heavy, et cetera, et cetera. And then when the motor's in there, in the rocket too, you have all that weight on the back end of the rocket. So as soon as you add some of the nose weight clay, it starts to balance out. And like I said, you'll be able to do that with the string test. So there's instructions
Absolutely.
on that. If you take a look at majority of your instructions for most of the Estus and custom rockets and even a SEMROC, they will explain how to adjust that if needed. So make sure that you read your instructions.
Absolutely.
Because that is definitely in most of those. And then
my favorite method of testing for stability these days is actually using a simulation like OpenRocket,
Yep.
which is, hey, get it free. There's also, I like RockSim, that you have to pay for, but I like them both. I use them both. But OpenRocket's free, and it'll give you those numbers once, you can, there's designs of rockets like kit rockets are available to download usually from the Apogee website's one place or any manufacturer. So for any kit, and you can also go online and download stuff for any Estus rocket that you choose to build. And if you start to get into designing your own rockets, that is the tool that you need in order to make sure you're stable. You can of course do your spin test if you want. I remember doing that as a kid a couple of times, going, "Oh, this is making me dizzy," but now I do it in the computer, and it makes, for me, I'm a computer geek, so I love, tinkering with designs and stuff. And you'll find that if you get started in a software package like OpenRocket, you're actually going to, if you're like everybody else, you're going to start designing rockets that are, how ridiculous can I make this and still be stable? Right. So, minimum diameter, which is essentially the diameter of the rocket is the diameter of the motor, and see how high you can get it on, having a rocket weigh as little as possible with the beefiest motor possible just for fun. Now, that's only in a virtual environment, so don't go ahead and start building that stuff. But it is fun to check out to see how high can you get a model rocket on a standard motor and going through the design and have it be stable. And it'll tell you if it's not.
So there's another point here on number 5. Oh, and we had talked about this. Actually, Jim, if you could explain that one a little bit, when conducting a simultaneous launch of more than 10 rockets, I will observe a safe distance 1.5 times. So yeah, that's going to be fun. I know if a lot of people starting in rocketry know about this.
There's something that happens occasionally if conditions permit it and there's no fire warnings or anything. It's called the drag race. And there is nothing more fun than to get a bunch of the same kits together. Like Estus Goblin is a great one. An Estus Goblin drag race. Now, those are small kits. They're model rockets. But to see 10 of them lined up and all going up at the same time all at once, that is a sight to behold. It's a lot of fun. And that as you get into higher power, that's also possible to do in higher power given the right circumstances. But that is that's usually in a club environment where they have a big launcher and it's a big launch, and it's, you don't want to necessarily do drag races like that on your own because you may not have the right equipment, or you might be straining your battery on your launcher, because if you have just an Estus launcher, it probably won't be able to handle it. But at a club launch, it's a lot of fun to see 5 or 6 goblins all going up at the same time. That's called a drag race. But when they say I will observe a safe distance of 1.5 times the maximum expected altitude of any launched rocket, essentially that means, okay, I've got a Goblin with a C motor that's probably going to do about 500 feet. I want to be 750 feet away from that. And there's many reasons for that. There's a lot of reasons for that. When you're launching multiple rockets, these things are traveling a couple hundred miles an hour. I don't care how lightweight they are. The faster you go, the more mass, then you get hit with the mass, it's going to be accelerated. I mean, the ISS gets hit by a 17,000 mile an hour piece of dust and it puts a hole in aluminum. So It's the same concept. I mean, obviously that's a little exaggerated with a model rocket, but if you have 10 of them going up and 1 or 2 of them goes astray and does a horizontal launch directly at you, you want to be far enough away that you have time to react to it, regardless of, I don't care how big the rocket is. I don't care what motor's in it. If you follow that code and make sure you are a really long distance away, it doesn't matter if 4 or 5 of them go off flight. I've seen a drag race where rockets actually collided into each other in air, which is pretty amazing. And that can happen. I've only seen it once. And it immediately caused both rockets to go off the straight narrow course and go into a horizontal flight configuration, which is not exactly what you want. So, but it is a fun thing. When a good drag race happens, it's exciting and it's a lot of fun to watch.
And there are times that you'll see just like 2 or 3 rockets launched at the same time. It's very rare that you'll see 10, but there's actually been some world records set where there's been more than 10. So, take a Google at that when you get a chance. But
yeah, was that the one where there's 250 that went up? Something like that. I don't remember, but it was all coordinated out by professionals at that level. So, well, that kind of brings us into the launcher, which I guess I'll start off with. Yeah. That's point number 6 on our model rocket safety code. And it states, I will launch my rocket from a launch rod, tower, or rail that is pointed to within 30 degrees of vertical, straight up essentially, to ensure that the rocket flies nearly straight up, and I will use a blast deflector to prevent the motor's exhaust from hitting the ground. To prevent accidental eye injury, I will place launchers so that the end of the launch rod is above eye level, or will cap the end of the rod when it's not in use. A little bit to unpack here. Basically, when you start off a model rocket, there's a guidance that lifts it, that keeps it straight and headed in the right direction. So that gives the motor time to push the rocket to an acceptable velocity, which is 30 miles per hour off the rail or off the rod. That is the thumbnail. That rocket must be moving at 30 miles an hour when it leaves that guidance and it to go straight up. That's one of the first things I learned in rocketry is don't use a slow rocket because it will go off course. Make sure you're at least 30 miles an hour. And the guidance can be a metal rod that's usually 1/4 inch. And on the side of your rocket is it's called a launch lug. It's essentially a little straw that the rocket goes and sits down on the pad. And when the rocket takes off, it will follow that rail or that rod up, and then it'll exit it. And by that point, it should be fast enough that it's actually going straight.
Right.
Now, there's also a couple other things. The launch rod is your basic one. We all have them. They come in different sizes, but for the most part, 1/4 inch is the one that you would be using if you're just getting started. There's also something called a rail, which is basically just a piece of shelving. It's like a C-clamp configuration. It's like a big rail, a big rod. And there are things called rail buttons or that go on the side of the rocket instead of the launch lug that guide that rocket all the way down. Now, the thing about the rail is that it's a lot stiffer. With rods, a 1/4-inch rod will flex a little bit. And sometimes if there's wind blowing or if it's an energetic motor going off, it'll create something called rod whip, which makes the rod oscillate as the rocket's leaving the pad, which could cause a little unstable flight. You don't want that. So as you're getting bigger rockets, you will more than likely need to use the rail, which keeps it straight for 6. I have rails in 4 feet, 6 feet, and 10 feet sizes, just depending upon the rocket. But those as you get into higher power stuff, you're gonna want a more beefier kind of a launch type system. The other part about this, and this is basic common sense, is a blast deflector. Well, what's that? It's a piece of metal. It's the only point of that blast deflector is to make sure that you're not setting fire to the playa or wherever you happen to be.
Right.
And in a lot of, if you're out west in the desert or it's drier, and then Colorado, I know that you guys have had fires out there recently. That stuff will go up pretty quick, and all it needs is an A motor to get started. And once that starts, you better be making sure that you're putting that out as quickly as possible. Blast deflector will prevent that from happening. I've seen launches in my area. I live in Ohio, which can be fairly humid and wet, but I've seen cornfields catch on fire from a launch and from a large motor that had an issue. But the blast deflector kept most of the flame from hitting the ground and getting those old corn stalks to go. But there still was a fire that was immediately put out, and it was a launch, so there's always going to be fire suppression equipment there just in case, and that is highly important, especially if you guys are out west. Do not set anything on fire. Use a blast deflector. It could be an old tin can that's been rolled out and flattened. It could be an Estus blast deflector, which they sell. It's essentially just a piece of steel to make sure as that hot gas is coming out of that hot nozzle, that it will hit that metal and not hit something that could catch on fire. Real simple, real basic.
So I have a quick story to tell. I did not have my rocket sitting on the side of a rail that had a blast deflector. So when my rocket took off, it actually created a hole in the ground. And, the people who volunteer at these clubs, that's exactly what they are, volunteers. And having to find other dirt to shovel into that hole, it's a pain. So you want to definitely make sure that you have a blast deflector under your rocket. It was a simple mistake that we made. A few people that were with me missed it, and it caused a lot of cleanup. So, even just for, courtesy, make sure you have a blast deflector on your pad. And that goes for low power and high power. So that's just something I wanted to hit on.
Yeah, well, no, it's true. Especially if you're, because most of the time launches take place that a landowner owns that land. And it, in my case, it's usually a farmer. And the last thing you want to do is to, by the good graces, they're letting you launch on their land. And you never, ever, ever want to do anything to make that landowner second guess themselves as to why that was a good decision to let you fly rockets there. Because there's a lot of clubs that have lost their land and their launch site, and they weren't able to launch rockets, and that's no fun for anybody. So a little bit of courtesy goes a long way in this field of ours. So I guess the last part is about just make sure you don't poke your eye out on a launch rod.
You'll poke your eye out. It has unfortunately happened before, even with experienced rocketeers. We walk over to your launch pads. We don't put the little safety cap on there. Let me talk about that little safety cap. So the same pin that goes into your launch controller that we talked about earlier usually has a little streamer or a little tie onto it, or like a little elastic band that then reaches over to a small orange or yellow cap. And I've seen it in different colors too. That cap technically goes on your launch rod after your rocket is taken off. So what I recommend is when you launch your rocket, you see it go up in the air. Keep your eye on your rocket until you see it come down, right? When you pull that pin from your launch controller, immediately walk over to your launch pad with that cap and that pin in your hand and just put the cap on the launch rod. And this is good for the park. This is good for anywhere that you are using your own personal devices. Now, at a club launch,
absolutely,
one of the reasons that you see it on a riser or you see it on like a workhorse or something similar is because that's exactly what it does, is it puts it above eye level. And I can't tell you how many kids and how many people that I've had to help, and I'm a short guy, but I'm over here on my tippy toes helping them put their rocket on these launch rods because I want to make sure that the kids, have their help when they need it. But the reason that they're so high is they don't poke your eye out. Now, if you're like Mr. John Bronner over there with Cloudbusters, and that guy's, like 6'5" or something like that, he has no problem. He'll poke his eye out either way because we can't get past that tall dude. But I'm just saying, I have to stand on my tiptoes to help kids put their rockets on the launch pad and clubs with the sawhorses. So that's why. So I just had to tease John there a little bit because hopefully he's listening.
I'm sure he is. We have a lot of listeners, and it's nice to be able to like mention names on that. It's like, hey, how's it going? Like, hey, Casey. So that was for you, Casey. Anyway, so that leads us into the next point, and we're almost through this, guys. I hope you're enjoying it. It's the
it's fun to
size
talk about,
of the
really.
rocket. So Jesse, I know it is
so,
actually. I mean, it's always good to revisit this stuff.
All right, we're going to take a quick break. Be right back after this. It's time to talk about our sponsor, eRockets.biz, your home for unique model rocket kits, as well as the world's largest selection of model rocket parts from Semrock. In business since 2009, eRockets doesn't just stock many of your favorite in-production kits, they also produce their own versions of popular out-of-production models many of you have come to enjoy over the years. So an item that I am interested in that I wanted to talk about is called the Semrock Joe Fin Jig 2. Now, you want to get your fins on straight. Semrock sells this really nifty little fin jig that's good for rockets up to 2.6 inches in diameter. It sits on top of the rocket, it straps to the rocket, and it helps you get your fins on perfectly straight for aero-straight flights. Retails for $65.99 at eRockets.biz. It is a cool little product. You need parts for your own custom builds, that's not a problem. eRockets.biz supplies the Semrock line of airframes, nose cones, centering rings, motor mounts, and so much more. eRockets has more rocket parts available than anyone on Earth, so check out eRockets.biz today to learn more. eRockets.biz. If rocketry scares you, buy a train set.
Daniel loves your model rocket questions. If you have any, send them to noob@themodelrocketshow.com. That's N00B at themodelrocketshow.com. Now, back to Daniel.
So I touched on size a little bit earlier today, and it's not really size more than the weight. So let's go over this real quick. Number 7, my model rocket will not weigh more than 1,500 grams, parentheses, 53 ounces, at liftoff. That includes the motor size, guys. Okay, so let me read this again.
Yes, it does.
My model rocket will not weigh more than 1,500 grams, 53 ounces at liftoff, and will not contain more than 125 grams or 4.4 ounces of propellant or 320 nanoseconds or 71.9 pounds a second of total impulse. So, Jim, I will let you talk about impulse, right? But let's talk about the rocket itself weighing more than 1,500 grams. So, when you start taking a look at the model rocket motors and the sizes and stuff, once you get certified into high power, you can start surpassing those depending on your level that you certified in, and we can walk up the ladder to those. Yeah. But for all intents and purposes, 1,500 grams or 53 ounces of weight of the total rocket with the motor, that's a lot. And that could be a fairly big rocket. So I remember back when I was in middle school, Mr. Buffalo, my shop teacher, he was always adamant, is like, when you build your model rockets, and he would always say model rockets. And I think that's key here because we're talking about model rockets. We're talking about the small ones that you can buy in the hobby stores. You can buy at some retail stores, right? Not the ones that you have to go and order online from manufacturers and your friends and start getting all crazy with that stuff. But the model rockets, he would always stress, when you build it, don't use a ton of glue, don't use a ton of clay, don't use a ton of paint. You want it to stay under 1 pound. And I'm like, how is this rocket going to ever be 1 pound? So then we go over to, that's when you start getting into the BT-80 tubes, which are 2.6 inches in diameter, right? And some of those rockets can weigh more than 1 pound. And we had a guy that made a Mean Machine clone out of 2.6 inch just regular Estus body tubes. And this thing was massive. It was like 9 feet tall. It was huge. Wow. Right? And that thing was over 1 pound. So guess what? The motor couldn't lift it. And it sat there and just made a mess. So the weight is important, guys. And I mean, there's different ways that you can measure that out. 53 ounces is pretty easy to do, like on a food scale. You can go to Costco or Sam's Club or even Walmart and buy yourself a food scale. And you can measure your rocket's weight by putting the motor inside of the rocket and weighing the entire contraption. At that point, you know what it's going to be when you fill out your flight card at a launch event or when you go out to the field yourself or the park or wherever you're able to fly your rockets. So that's a small tip that I just wanted to touch on. And then as far as the propellant, Gheem, you're a propellant expert for all intents and purposes. Can you touch base on that? And
I don't know about an expert, but but I'll try and tackle it, though. I'm just a guy. When we're talking about propellants and model rockets, there's a couple of things that you need to, how much of the stuff is in the motor and how much thrust is that going to give me when it starts to burn. Now, when you're talking model rockets, real simple, basic rule of thumb is 125 grams or less. And that could be either the two types of propellants are ammonium perchlorate, which is used in the composite motors, or Estus black powder motors, or Quest, they used to make black powder motors. So you can still get some of those.
Right.
So you can't have more than 4.4 ounces or 125 grams of any kind of propellant in a model rocket. As you get up in more propellant, you're getting, the way that a motor works is it burns that stuff. And that stuff, as it's burning, creates a pressure. And that pressure builds up inside the motor, and it has to go somewhere. So that's where it goes out the nozzle, which is the hot nozzle. That pressure is that simple reaction of having that stuff come out of that nozzle, because it's the only place it's going to go, is down, which will push the rocket up through simple physics. I'm not even going to go into any of that part of it, but, and they talk about how much a Newton second is, or how much, and that's also like pounds per second. But there's all kinds of stuff, and I'm not going to get too deep into it because that would probably bore people, and I'd probably get confused as I'm talking about it anyway. But when you're dealing with the amount of Newton seconds, it's basically how much stuff is coming out of that nozzle at what rate, and how like mass and weight. How fast is it going, and how much is coming out? That's thrust. As it goes through that little opening, the only place it can go, it's going to speed up as it goes through the nozzle because it was inside a motor, which is a big open area. It's going to compress the gas and push it out that nozzle. How fast that happens is what your thrust is, and it's measured in Newton seconds or pound seconds. And that is just don't get too confused or too caught up in the Newton seconds or what's a Newton second. It's essentially just means how much of that stuff is coming out at a given point to make that rocket fly. That'll give you a rough idea of thrust. There's something called specific impulse, which is kind of like, I guess it could be like the car mileage. How much mileage or how much performance are you getting out of that rocket motor, and how in 1 second? And it's called specific impulse, and the numbers go all over the place based on the motor that you're using. They could be anywhere from like a low efficiency motor, like a black powder motor, to a really high efficiency specific propellant thing. But specific impulse is just a word that gives you an idea of how efficient that motor is, or how well it is at getting all that stuff out that nozzle in a certain amount of time. So not much more needs to be said about that at the model rocket level, but it is important to know, and just giving you a basic idea of what thrust is, that'll help you get better, so that when you start thinking about the rocket that you're building, you can actually choose the motor to fit the rocket. The wand chooses the wizard. Yep. The rocket chooses the motor. And how you build that rocket
very true
will determine what motor you're going to use for it. And there's things called thrust curves, which you can find online. There's a great website, guess what, called thrustcurves.org, I believe it is. Yep, but there's also an app for iOS and Android that you can get that information on a specific motor, and they've got all of them. I'm looking at thrust curve on my iPhone all the time as I'm dealing with different motors to say, okay, I know this rocket is this weight. I know I want it to go this certain altitude, and I know I'm going to keep it in an F-class motor. Okay, what's the best F motor for that? Some of them are going to be fast burn, which means they're going to have a lot of kick, but they're not going to burn very long. They're going to push it off the pad. So that'll give you your 30 miles an hour if it's a heavier rocket off the rail that we talked about. But then other motors burn a little bit slower. They burn longer, but they're not going to make that thrust off the rod as fast as a fast burn propellant would. So there's different things. And thrust curves is the key to model rocketry, to know which motor goes for which rocket. Because you could have that, that big mean machine that's going to sit on the pad and make a mess, like Jesse talked about,
right.
Or you can have a beautiful flight, or you can put in such a high performance motor on such a lightweight rocket, you'll never see it again. And, if that's really what you want to do, make sure that you have a safe, where sort of it's going, so it's not going to be in anybody's way or be possible harm to anybody. So the whole point is to get it back and fly it again. I mean, because that's what you want to do. You want to fly rockets, right? Best way to do that, build one and get it back and fly it again.
Yep. One thing that I wanted to correct myself on, I said 320 nanoseconds earlier. I apologize. Jim, thank you. It is Newton seconds, right? So once again, if you're interested in what that's all about, that's your Google machine, man. And obviously we were, Jim did a lot just in number 7 talking about the flight safety. And to reiterate, number 8 is actually flight safety. And what it says, I will not launch my rockets at targets, into clouds, or near airplanes, and will not put any flammable or explosive payload in my rocket. So there's
pretty straightforward.
Yeah, and there's a lot of things that we need to touch here. So we'll do these step by step here. So not launch your rockets at targets. So I used to be an admin on some Facebook pages for rockets, and I'm not going to lie, if I saw people posting some stuff that was going horizontal, I would delete it. And the reason why is because that's not safety code. It's not about, I was violating your freedoms by taking away your speech. That's not it. It's, that paints a bad picture. So when I saw something that was not flying, it wasn't necessarily a model rocket. It could have been a firework or something, but just like Roman candles and stuff, right? You don't point those at people. That stuff is meant to go up. So are your model rockets. So don't use model rockets for targets, guys. That's not good. Please stay to the code.
Absolutely
right?
not.
we want to keep our hobby, and one of those is not using them for those purposes. So please keep our hobby, and those of us that want to continue it want to fly. So don't jeopardize that, please.
And just a quick point on that, if I can add, is there's a lot of model rocketeers that have been doing this for years, and there's been times where something may have happened that got into a news story locally,
right,
and it caused a great furor about that wasn't safety code, and then all of a sudden the government's going to come in and shut us down because they don't think it's safe. You don't want that. You want to enjoy your hobby and have fun. And there have been some incidents where people didn't follow the safety code, where there's a possibility that the entire hobby could be shut down. And I cannot stress that enough. That there's been events that have created that talk. And I love this hobby and I want to continue to do it. So I'm going to follow the safety code because I am not going to shut it down for everybody else,
right,
everybody in the country. It could potentially do that if somebody does something really stupid.
So number 8 comes up a lot. And obviously, I will not launch my rocket into clouds. Why is that important, guys? Do we need to talk about it?
Keep an eye in the sky, like I always say.
Exactly. So, I mean, it's all for visibility. And, just low-flying aircraft. Unfortunately, we have, in most cases at launches, an FAA waiver. And, most of the time, there will be some private, persons who are flying that don't have the radio communication with any one of those towers, and they may be taking a ranch or a farm type airplane or something that they use to, do crop dusting with, and they might be flying through your range. So if you are flying into clouds, there's usually a low ceiling cloud cover. If you're at a national event launch, or if you're at a planned launch with a club, in most cases, our RSOs and our LCOs and everybody, they're going to be aware of majority of the cloud cover.
Yep.
And in most cases, we might even be able to say that's sitting at about 10,000 feet. You'll hear, people will be able to tell things because they've been doing it for years, right? And obviously flying into clouds, you're not going to have a ton of clouds that are super low when you're flying model rockets. But once you start getting into the Fs, the Gs, the Hs, and you start walking up that ladder, you can potentially get into clouds. And if you've been to some of these high-power rocket launches where you can launch your Estus rockets too, some of those guys do have the ability to get to the point where the rocket is not visible anymore. And I lose visibility after about 2,000 feet. And after that, I can't see anything. And sometimes you can see the smoke trail after the fact, but by the time you see the smoke trail, the rocket's even higher. So, all your common sense, guys, you want to make sure that there's nothing flying in the air, or there's potentially a bird. I mean, I've seen some really close calls. Another rocket might be coming down, or like Jim had said earlier, there could be some that collide, unfortunately. So just when we talk about clouds, just use caution, use some care.
I mean, even like I'm one of the people that likes to watch the entire event. I like to see my rocket take off the pad. I like to see it arc over gently at apogee, and I like to see that ejection charge pop out the recovery system. Nice. And I like to watch it land. So I can actually walk and know exactly where it is. So I'm not going to search for it for a while. The higher you get, the longer the distances you're going to be walking. And even with model rockets, they're small, so they're hard to keep an eye on. So, when I launch model rockets, because I'll launch anything from a half A all the way up to an M, if depending on my mood and my availability. But the smaller rockets can be hard to keep an eye on when they're flying at 500-600 feet. Sometimes, if they're small, so put some metallic tape on it so that it'll glisten in the sun or something. Make it, bling it up a little bit. Put some color on it. It'll be a lot easier to see in the sky if you have an orange rocket as opposed to one that's sky blue. Yeah, so it's just, and it'll also be better you'll be able to see the entire flight, which is part of the experience. Which is, I don't even film any of my stuff. I just like to just watch it, and experience it without anything in front of my face, like a camera or even binoculars or anything. I just like to watch it. That's me. Everybody's a little different with that. Some people like to, video the thing from start to finish. Good for them. That's not me, but I like to just experience it and see the whole thing, and it's also safer too, which also gets into that last point of I will not put any flammable or explosive payloads in my rockets. It should be something that is a given. That is, right. Yeah. But obviously, if you make a ballistic missile, you could kill somebody. Period.
Yeah.
I mean,
gotta say it.
You have to say that. You could cause property damage and get sued or something, or be liable for $1 million worth of property damage because of something stupid like that. Don't do it. Don't even think about it. It's not, if you want to do that stuff, go and watch a professional fireworks show, and you can see all the explosions you want, because that's done they have their own safety code when they do fireworks. Then it's completely different than ours because it's a different thing. But if you want to see explosions, go to see a fireworks show. Don't go to a rocket launch for that. And don't even think about trying to do anything like that. It'd be really cool if I did this. I mean, yeah, you could joke about it. My kids on my TARC team joke about sending a little package over to our rival schools. But, but when it gets down to it, you don't do that. You don't and that also means no active guidance or any of that stuff, because then it becomes a missile.
Right.
You really got to know what you're doing. When you start out, you just want to just get it up, get it down, and have fun. And that's really what it's all about.
So, everything's said and done here. We got a few more points that we want to talk over. The next one is launch site. And there's different ways to calculate the area that you need for a launch site. Obviously, you want to stay clear of trees and stuff like that. But if you guys don't mind, let's go over that real quick. Number 9 being launch site. I will launch my rockets outdoors. Okay. I will launch my rockets outdoors in an open area that's at least as large as shown in the accompanying table. And in most of the rocket safety codes, you will have a small table on these. In the safe weather conditions with wind speeds no greater than 20 miles per hour, that's key as well. I will ensure that there's no dry gas close to the launch pad, and that the launch site does not present risk of grass fires. So once again, a few important key things here when we talk about the launch site. Let me reiterate on the first. Launch your rocket outdoors, guys. There's not really going to be a situation, even in a sporting event, that you're going to potentially have an open area to launch rockets. I mean, if that is something that's usually done by professionals with a team or something like that. So, if you are asked to do a rocket launch, it's been a thing lately to do gender reveals with some model rockets. If you do it in a park and you got a wide open area and you've looked at the table and you have decided what motor you're going to use and everything, it's actually kind of a fun thing to do. And there's different ways that you can do that. Investigate how to do that safely, though. And please don't try to do that anywhere that's enclosed. Big atriums and stuff like that, that's a no-no. I mean, because if that rocket hits the ceiling, you never know it's going to land. And once again, it may still be in motion. And if it is, it's going to go somewhere else. And you don't want to see that show, not safely anyway. When you talk about your open areas, the graph that they have is at the bottom of the NAR safety code that's here on the website that we're looking at. And if you look at some of the documentation that comes with your model rockets, I have the Alpha Mini Book of Model Rocketry. Now, it doesn't actually have the table enclosed because the table was updated since this actually came out, but it does actually have some instructions when you open the booklet, and it kind of talks about the launch area itself. You can hear me crinkling the pages there. So please review that if you have that in hand, because it actually does talk about it. And then here on the NAR website as well, they do talk about the safe spaces for the different types of motors that you're going to use. For example, if you launch a half A motor, that's usually a small 13 millimeter motor, it says to have a minimum sight dimension of about 50 feet. That's pretty big for a motor that's that size. But remember, those motors are made for tiny, tiny rockets, and they usually go out at sight really, really fast. So
yes, they do.
Yeah, so just...
how many mosquitoes have you lost?
We're not going to talk about it. and if you haven't built a mosquito, if you are starting out in model rocketry, buy a mosquito. They're fun, they're great, and it's fun to build like 10 of them and have on your desk. Or if you go to Hobby Lobby, buy a Luna Bug. Those are really cool too. And just keep those everywhere. Just have them in your bathroom and your desk at work.
I have a 3D printed one. I have a 3D printed one.
Oh, yeah.
It takes a little bit of a heavier motor because it's heavy.
It's bigger,
but,
yeah.
But
they're fun. They're cool.
A lot of fun. They are.
What is here on number 9? Gene, let's see.
Okay. Let's not have wind speeds greater than 20 miles an hour. Okay, real basic. If the wind's like, you've got a really light rocket, right?
Oh, yeah.
Yeah. You got absolutely with like weathercocking. If you have a really lightweight rocket and you've got 30 mile an hour winds, guess what's going to happen to that rocket? I don't care.
It's going to go bye-bye.
It's going to go sideways. It's going to go that way, which, that's a real basic one, but it's important to reiterate that if it's too windy, sometimes you get launch fever, especially when you're just getting into it. You want to launch everything all at once, but you got to watch the wind speeds. You got to wait for that window for the winds to die down. Usually around here, it's in the evenings, like early evenings, for when the wind gets really kind of chill. But you don't want it any higher than 20 miles an hour. And, for the TARC team, that's a very specific kind of a competition that I'm in where the kids have to get specific altitudes and off of specific motors. So they have a little anemometer, which is a wind speed indicator device that they know exactly what the wind speed is at a given point in time. And and they know if it's over 20 miles an hour, they're just going to have to wait or not go if it's going to,
exactly.
It's just basic, simple, no more than 20 miles an hour. And that's that goes all the way up to high power. There's a little bit more latitude. I think it's like 28 miles an hour for the high power stuff, I believe. I could be wrong on that. So if I am, please correct me. But anything higher, I don't usually want to fly in anything at 20 miles an hour anyway. So, and I'll just sit and hang out for a while.
The next thing here, I live in Colorado, and you mentioned this earlier too, Gene. So, you will ensure that there is no dry glass. My gosh. I will ensure that there is no dry grass close to the launch pad and that the launch site does not present a risk of grass fires. In Colorado, between 2019, 2020, and this last year of 2021, we had over 30 launch events scheduled between all the clubs in Colorado. We were only able to launch 19 out of 30 of those. So the other 11 events were unfortunately closed due to fire bans. So if watch the news, California, Oregon, parts of Nevada, even into Montana, down by even as far east as Nebraska, Colorado, Wyoming especially, down into New Mexico. We had grass fires all the way down from Oklahoma to Texas. I mean, the entire Midwest to, the western part of the U.S. got fire banned.
Big chunk.
Yeah, and for, just, no moisture. And, this year is no exception. Unfortunately, in 2021, I was blessed to go to a ton of events in Colorado. We even had NSL here down in Alamosa, and it was a fantastic year. I was able to travel to a couple other states and go to a few other launches. But, we don't have any moisture right now. It's, the beginning of December, guys, and we're in the 70s. I don't think 2022 is going to be that lucrative. We don't have the moisture. And the launch that we had scheduled for December 4th over at our Northern Colorado rocketry site got canceled. So it's a bummer, guys. And one of the reasons that we don't want to fly is because you do risk the potential use of grass fires. So for all you model rocketeers that have went and bought a launch system, a launch pad, if you see a lot of dry grass in the area that you're launching, try to move over to some pavement, or you launch from there maybe and into the grass. I mean,
or dirt.
Yeah, or if you can find some dirt, like a dirt road is also pretty fun and easy to do that on. Most of your rockets won't get scratched or damaged in most cases. But if you see the dry grass, just try to sway away from that and maybe wait for another day or another time, or even do it if there's snow on the ground. That's always fun.
Launching in snow is fun. I remember doing that a lot. So,
but that
you also touched. Yeah, it's going to torch up real fast, and once it gets started, you'd be surprised at how fast it goes.
Yeah.
So you just use a little common sense. You don't want to hurt the environment by starting a fire. That's the last thing that I would ever want to do. And that you touched on a point though, is it'll land safely. How do you get your rocket to land safely? A recovery system. That's the point number 10, and we're almost at the end of this list. Woohoo! The recovery system is essentially, how does that rocket come down safely, right? And for lighter rockets, you can use what's called a streamer, which is basically a thing that flaps in the wind, it's a strip of a plastic or some kind of specially fire-resistant crepe paper stuff. It's just a long rectangle streamer thing that essentially waves in the wind and slows your rocket down. For lighter rockets, or Estus or model rockets, the lighter ones can use a streamer and come down at very, very slowly, but still enough. And if you use a bright color on your streamer, you will also be easier to see it.
Right.
So most of the recovery systems, even in the high power stuff, use parachutes. Estes has their great, well-known parachutes that come with most kits. They work pretty well. And the way it works is after the motor's burned out, there's a little delay charge that is just kind of sitting there burning away. And when that delay charge is done, it hits a little spot of black powder that causes a very small explosion going the other way of where the rocket was traveling. So that pressurizes where the nose cone inside the body of the rocket. The nose cone gets popped off because the pressure changed. The parachute's connected to the nose cone. The nose cone is connected to the rocket. And it all stays together. And then the perfect thing is at apogee, which is your slowest point of travel when it's going up. The parachute pops out at apogee, and the parachute inflates, and it brings your rocket down nice and soft. And I've landed on rocks and stuff, but with a good recovery system, that rocket can be turned around and flown again. And it also means that when you use the recovery system, you're going to put something between that little explosion that's happening in the rocket motor and the parachute, and it's called recovery wadding.
Right.
Estes sells recovery wadding. It's essentially a fireproof, biodegradable toilet paper, essentially.
Yep.
But it's specially treated so that it's not going to catch on fire, and that'll prevent the heat from getting to that plastic parachute that could melt it and make a big mess. Then you wouldn't have a parachute; you'd have a ball of plastic.
Right.
But there's also stuff that, as you get into higher power, it's affectionately known as dog barf, but it's essentially fireproof cellulose insulation that's used in a house. It's fire retardant, and it's basically paper. So that also works as a recovery. But when you start out, stick with the Estus recovery wadding and make sure you put enough in there. Not too much that it's going to get stuck in the rocket and it won't push your parachute out, but enough that it will allow the parachute to come out safely without being singed or burned or melted or anything like that. If you get 10 miles an hour on a recovery coming down, that's pretty good. The ones with the Estus kits, they already have given you the right size parachute for that. If you go streamer, bigger is always better with a streamer. It could be obnoxiously large as long as it's small enough that you can pack it into that rocket body tube and it'll come out safely. So make sure that it slides in and out easily. You don't want to put too much that it'll get stuck.
Exactly. And then just to reiterate, do not use toilet paper. Use the recovery wadding.
Yes.
It is treated.
Yes.
There are ways to treat toilet paper, but that's not how you want to try to do that at home. It's not as cost effective as you think. Just buy a package of recovery wadding. It actually goes a long way. And then if you don't have a place to buy that, or you don't want to order online, then go to your local hardware store and see if you can pick up some of the dog barf. One bale will do you for life. Share it with your friends.
I have a bale that I start with my rocketry team. I bought a bale of it, and we're still on it, and we're on our 5th, 6th year now, I think, something like that.
Yeah, you're gonna have that forever.
And we're still going through it. Yeah, so it goes a long way.
All right, and talking about all the safety and everything brings us to number 11: recovery safety. I will not attempt to recover my rocket from power lines, tall trees, or other dangerous places. a while back, we had a question that Rocket Noob actually answered for a caller that I believe that was Kirk. But just to reiterate, it actually does say here, do not recover your rockets from power lines, tall trees, or dangerous places. So power lines is a given. I am not electrically shockproof. I mean, I look at my outlets and I get shocked. I walk on carpet and I get shocked. The last thing I want to try to do is take any type of extension pole or any type of crafted device and take it to a power line to try to take down my rocket.
No.
Argonia, Kansas, for some of our big events for, Airfest and, Argonia Cup and stuff like that, there are unfortunately power lines there. And some rockets do get caught in those power lines. They do reach out to the electrical companies and they do come out like at least once a day to take those rockets down. And then they give them to the club and the club gives them back to the members and everybody's happy. If you don't have that option, the best thing you can do, in my opinion, and, we've talked about this before in other podcasts and, just in other discussion forums and everything, call the electric company. Let them know that you have a model rocket. You can even call it a toy if you need to, stuck on a power line. Tell them what intersection, what street it's on, and they'll go down and they'll take it off. In some cases, you might get lucky. They might be able to return it to you, especially if it's like a out of production D-Region Tomahawk for $100 that you didn't want to lose but got stuck in that power line. You might only get half of it back, but at least you got something. So, just use some common sense. Don't try to get it down yourself. Most of those things are too high anyway. And unless you're a certified electrician that's on the clock with a bucket truck, don't try to do that, please. Let the professionals take care of that. Trees.
And even a tree. Think you want to climb a tree and then slip out of a tree, break your back, and you're dead.
Yeah, that's it. I mean, just no trees, guys. We talk about ways to get things out of trees. There was I'll go ahead and say it. And there was a slingshot method that we tried, but then we retracted using the slingshot because you're now firing a slingshot into a tree. You have no idea where that thing's going to end. And once you got something at the end of the projectile, it's not safe. Don't do it. It's not worth it. If your rocket gets stuck in a tree, let Mother Nature take its course, salute it goodbye, and go on with life, guys.
And we've all lost them, but that's part of it, is that like going into it knowing that eventually you're going to get something stuck in a tree. It's kind of an inevitable thing. You live with it and you move on. That's why you buy two of the same kit. That way you've got a spare.
I did buy another D-Region Tomahawk, so I got a story for that for another time. But yeah. And then other dangerous places. Let me touch on this one real quick, Gheem. So in Pueblo, Colorado, where we had NARM 60 back in 2018, I talk about it all the time on Rocketry Show. We have a huge, it's a canyon. There's actually 3 different small canyons around there. And, I can't go down that first one. There are some Rocketeers that are brave enough to do it, probably more agile than me. I'm closer to 50 than 40, right? My body can't do that. I cannot go down in that canyon, and I'm not going to try. When they say dangerous places, if you wouldn't do it, just, if you get that urge that, no, this isn't good, you know what? Trust your instinct and don't go down there, because you slip on something. I mean, a rocket, even $100, a Lock 4 isn't worth your life. And going down into that canyon, you got to be careful. I know that there's a lot of different ranges around that have different things. You got to be careful of stickers if you're going to certain grasslands, right? I mean, cactus can get you. They can bite really hard. They can go through shoes. That's not fun. And you don't want to have to go and get a shot or soak your foot in Epsom salt if you're stepping on cactuses and stuff like that too. So dangerous places can mean a lot of different things. Use your best judgment, use your intuition, and, trust your instincts, because if you're not safe, if you're not feeling good about it, then you probably don't want to do it. And that's from personal experience partly. And it's, from common sense too, because, we got to watch out for each other, guys. So.
Yeah, and that's why I love this hobby. It's like we all kind of take care of each other because we love what we do and we want to continue to do it, and it's a lot of fun. And all this safety code stuff, it sounds like it's a lot. It's really not. It's just think about what you're doing before you do it. I can't reiterate that enough. It's just basic common sense. Follow a couple of these rules and everybody's happy, and it's no big deal. It's like, I'm always following the safety code. I don't have to say, hey, I'm following the safety code. No, I'm just going to go fly rockets. But in the back of my mind, I'm making sure I'm doing what I need to have a safe, fun time. And that's the best approach that works for me. And everybody's going to be a little bit different about that. If you want to broadcast safety code, go for it. Good for you. I just do my own thing, but I make sure that I'm within those parameters because I love this hobby. I love the friends I've made in this hobby, and I want to continue to do that until I can't do it anymore. And hopefully that's not going to be for a very long time because I want to continue to fly. And that's all there is to it. And all these rules, they kind of become part of you after you go to a couple launches, after you launch some stuff. It kind of gets ingrained in you. And if any of you guys have went to the Hot Nozzle Summer event, they were very big on the safety code stuff and they were following it, but they were having a great time doing it. I saw all the pictures and I trolled the Instagram and it looked like it was a great time. They followed the safety code to the letter and more so than some clubs that I've seen, at least from what I was gathering from what the event was. So good on them. Good for you guys. That's the awesome part is the whole point is to have fun and go and hot nozzle away, but do it in a safe way. And that way it's even more fun for everybody else. And you've got some great stories to bring back to your friends to get them involved in rocketry because it's a great hobby and it's a lot of fun.
So there are two more things that I do quickly want to touch on. And Jim, hopefully you could help me reiterate on those. The first thing is, for those of you who are looking to level up, we do have a lot of first-time flyers that are in part of universities or they're just really anxious or go-getters or just whatever you want to call them. Very ambitious persons. And it's good to be ambitious, in career paths and everything. It's very helpful that you have a plan of action that you go and follow through with it. We encourage the same, but within your own safety. So just to be clear on a few things, if you do want to go for a high power certification and you have never launched a rocket before, guess what? The National Association of Rocketry and the AAA Rocketry Association do have guidelines that you can follow that have not only the rocketry safety code, but they have tips and tricks on things that you need to be aware of before you start leveling up. Now, there's a lot of natural builders. There's a lot of people who have functionality and good motor skills, doing anything from carpentry, doing anything, house related, even painting a house, even, working on a yard. There's some folks who just have that ability to naturally understand how a rocket could be put together safely and to get it to majestically work. We've interviewed a few people on the Rocketry Show that exactly have that ability. And you know what? That's great. We're not going to second guess how you build your rocket because if you can build a boat, more than likely you can build a model rocket. Okay. So there's a few things you need to understand with that. But if you're trying to figure out how to go and launch a high-powered rocket safely, go to those websites and look up level 1 high power certification. Tim Van Melgen, once again from Apogee, has a huge video series on that. Yeah, and tons of information on the newsletters for the Peak of Flight, and tons of different things that he's got available on the Apogee website. And then if you go to the AAA website or the National Association of Rocketry website, they have tons of tips and tricks for you to be able to do that successfully and safely. So even though the rules might be a little different between the model rocket safety code and high power certifications, there are stipulations and rules that you need to be aware of for level 1, level 2, level 3, all the way up to class 3 projects. So please, if you're investigating that stuff and wanting to do it, go read that information first. Get keened up to it. There's tons of books available as well. Gheem, what books? We've interviewed some authors.
The Maker series, how to make and build high power rockets. That's a Bible for getting into that stuff. That's probably the best resource that I would recommend.
And even the Handbook of Model Rocketry touches base on it from J. Harry Stein.
Handbook of that is the ultimate reference for it. It was written in the early 60s, I believe, but it has been revised and updated, and it is the book for anybody that's interested in model rocketry. And as you get into the levels,
it is a fun read.
It is. It's a lot of fun. I have a PDF of it, but a lot of if you're not into all the the book learning and all that stuff, and you just want to build stuff, that's fine. But take your time to do it and know what you're doing, because I know there's a lot of when I deal with some of my guys on my team, they just want to jump into high power. But you know what? I try and hold them back a little bit, saying, okay, well, if you want to launch this, what's the thrust curve on an H128 redline motor? You know, what, how big are you going to make the rocket for this? You know, and so you need to ask those questions, and I'll usually get I don't know. I said, okay, when you can come back and answer those questions, then we'll talk about it. So, know what you're doing is essentially my takeaway to my team. I want them to know, I want them to be high power certified. I think it's a feather in my cap that I've been able to bring them up that way. But I'm not going to just say, here's a motor and build something and then let's go fly it and see what happens. That's not the way this works. This is part of an education from my perspective of my team, is to say, okay, do these guys really know what they're doing, and are they really ready to do it? Now, the last level certification that I did was from the president of the club just recently, a gentleman by the name of Ben. Hi, Ben, if you're listening.
Hey, Ben.
He's been president of the club for he's a senior this year, and he finally got his level 1, but he was taking his time to do it, and he decided that he wanted to add electronics and dual deploy his level 1, a little bit of, and usually what you want to do is you want to build a good solid rocket, get it up and get it down. But Ben knows his stuff, and I let him go ahead and take that extra step because he wants to take his journey into level 2 at some point. So, and that's part of it, is using the electronics and doing electronic recovery, dual deploy. That's other stuff for later shows, or the Rocketry Show, which is what we are from. But start off just having fun with it, and if you do get your level 1, there's a ton of motors in that are go all the way up to I motors that are very, very powerful. There's an I-500 motor that I love to fly. It's a level 1 motor, but man, is it a beast. It'll take my fiberglass 2.6-inch Mad Cow Mantis up to 4,000 feet in a lightning second. It's amazing. So I have a lot of fun with those level 1 motors, but start off simple and small if you can. And make sure that it's built and it's going to be, and talk to your friends. If you're into rocketry, I'm sure some of your friends are involved in it. Make sure that you run ideas past people that kind of, or go to a club and talk to some of the old schoolers that are there. They'll help you out. Don't be afraid to ask questions, because there's nothing more than a rocketeer likes than to be asked questions about rockets. And they'll talk your ear off like we always do on the show.
Oh, yeah.
But
so,
because we love to talk about it.
There was one thing that Rocket Noob, and this is my closing comment for my end, Gheem, but there was one thing that the Rocket Noob, that Daniel had mentioned on a couple episodes of the Model Rocket Show a while back. And one of them was a question that he got asked, or it was just something that brought up about catching your rocket. Now, it's not actually here in the Model Rocket Safety Code. But once again, guys, let's use some common sense. If you have an Alpha 3 and you're sending your 11-year-old kid to catch that coming down, he potentially could injure his eye. Those are very pointy fins. Mm-hmm. If you have an executioner that's 2.6 inches in diameter and you send out your nephew Jacob to go catch it, those have very pointy fins. And the engine that probably has was a little bit bigger, and that could probably hurt the kid's eye. So, in Celebration of December and A Christmas Story, you'll poke your eye out, kid. Use some common sense, guys. I mean, it's not written in the Rocketry Safety Code. Don't make them add it, please.
That's a good point. Great point.
So, can you do it? You know what? You see pictures of it. It's fun if you do try it. But I mean, just use some common sense, guys.
Yeah.
That's all I'm going to say about that.
I don't let my team catch the rockets. I mean, I don't even care if it's a small one. I don't like the idea because, these are high school kids that I work with. And if one of them gets injured by doing something like that, then guess who's liable? So I'm doing it for my own self-preservation, but it's not something that I want to encourage.
I was at a launch a while back, and there was a Phantom 4000 that came down on some people. And a Phantom 4000 is a 4-inch diameter rocket. It's an old school rocket. Mm-hmm. They don't make them anymore. Matt still might produce them again at some point from North Coast Rocketry. But this was a few years back, and I had just gotten back in. I was a born again rocketeer, and I just got back in it. And I think it was at the end of 2016. And this Phantom 4000 came down on this group of kids that weren't paying attention. Oh. Now, here's the part that bothers me, Gheem. People were yelling, "Heads up! Heads up! Heads up!" Pointing their fingers in the sky, and these guys were over here busy talking about rockets, hopefully, and they weren't paying attention. And this kid got belted in the head with the fin can of a Phantom 4000.
That's gotta hurt.
Yeah, it's not good. That's kind of a heavy rocket still. It's over a pound. I think those were 2.2
Plywood
pounds.
fins.
Yeah. So, guys, when they yell heads up, don't try to catch the rocket. Look at it. Move out of the way. Get out from under your canopy. Get out from under the back hood of your car. Because guess what? The tailgate of your Honda Pilot that's up in the air isn't going to protect you very well from a rocket that's coming in sideways. So please pay attention and add that to your own personal safety code. So
I think that's a great place to end it. Use your own personal safety code, follow the rules, and and it's not draconian. You're not going to have to be sucked into this pit of rules. It's common sense to make sure that you're not hurting anyone and you're having a good time. So I hope that that Jesse and I have helped you guys out a little bit to get a kind of a feel for the safety code, because it's stuff, it's basic stuff, but it needs to be out there,
and we
want
to reiterate it for sure. So. And
it's always good to revisit it. I do it every year with new guys on my team. And I'm always going to, if anybody wants to talk rocket safety, sure, absolutely. And we hope that it's been at least fun for you and informal, and you get kind of a sense of what it is. But because we want you to build those rockets and fly them.
And you got some laughs with us.
Yeah.
We've seen
and
a
come
lot
and
of
ask
stuff.
us questions.
Yeah.
And, we got stories.
Now, how can you ask us questions? Okay, so the Model Rocket Show is a sister show of The Rocketry Show, which Gheem, I, and CG are hosts on, and The Rocket Noob is the host usually of the Model Rocket Show. But if you go to TheRocketryShow.com and you go over to the right-hand side of the screen, there's something that says Send Voicemail. And you can click on that and use your computer or your audio device microphone that's either on your phone or your computer, whatever it might be, a tablet, for example. And you can leave us a voicemail message. So if you want to go to that, to the Rocketry Show and use what's called our speak pipe and send us a voicemail. And with your permission, we'll put it on the air for either the Model Rocket Show or the Rocketry Show, depending on the topic and subject, of course. But that's the best way for you to get a question to us, as well as, sending it to, do we have a mailbag for the Model Rocket Show, Gheem?
I'm looking right now, so you caught me on that. There is an email form. If you go to TheModelRocketShow.com, that's all one word, TheModelRocketShow.com, it'll bring up a website, and there is an email forum. There is a way to subscribe. There is an about, and there's all that stuff that you can get a hold of us from. The email forum is probably the best link to get to. You just hit that, and you can get into the group. You can ask questions right in that groups. It's a Google Groups.io type thing.
Got it.
So there's all kinds of stuff there that you can hit and
we're
slam
on
on those
too.
buttons.
We're on Facebook, and we're actually on Instagram for the Rocketry Show. You can direct any questions that you have related to this to those as well. So yeah, send us questions, send us comments. Did we touch on something that you want to talk more about, or did we forget a subject on, all these 11 steps and rules? I try to be as clear as possible, but as the thoughts get into our heads, we kind of go back and forth a little bit. So I appreciate it, Jim. We covered a lot tonight.
That works.
Yeah.
Yeah, we really did. And hopefully, Noob, we did okay for you.
Yes.
So
yes.
We're helping out. So on that note, I guess you want to close us out, Jesse? And thank you for listening.
Actually, I like when you say it. You said it earlier today.
Okay, well, should I do that for this show too?
Yeah,
okay.
Yeah.
All right. Well, lead me into it then.
So, Gheem, without further ado,
keep your eyes in the skies.
Hey, that's our thing. I love it. Thank you.
All right, guys. Thank you for listening. See you later.
Thanks, Daniel.
This show is brought to you by the support of our sponsors and listeners. If you wish to support the show for just a few dollars a month, please become a patron by visiting patreon.com/TheRocketry Show. Don't forget to check out our sister show, TheRocketryShow.com, a program that is all about advanced and high-power rocketry. The views and opinions expressed on these programs are those of the participants and do not necessarily reflect those of Little Beth Entertainment or its sponsors.